understanding and the nature of understanding and what the essence of understanding is. Because understanding is something we aim for, everyone. We want to understand things. My claim is that understanding has to do with the ability to change your perspective. If you don't have that, you don't have understanding. So that is my claim. And I want to focus on mathematics. Many of us think of mathematics as addition, subtraction, multiplication, division, fractions, percent, geometry, algebra, all that stuff. But actually, I want to talk about the essence of mathematics as well. And my claim is that mathematics has to do with patterns. Behind me, you see a beautiful pattern. And this pattern actually emerges just from drawing circles in a very particular way. So my day-to-day definition of mathematics that I use every day is the following. First of all, it is about finding patterns. And with a pattern, I mean a connection, a structure, some regularity, some rules that govern what we see. Second of all, I think it is about representing these patterns with a language. We make up language if we don't have it. And in mathematics, this is essential. It's also about making assumptions and playing around with these assumptions and just seeing what happens. And we're going to do that very soon. And finally, it's about doing cool stuff. Mathematics enables us to do so many things. So let's have a look at these patterns. If you want to tie a tie knot, there are patterns. Tie knots have names. And you can also do the mathematics of tie knots. This is a left out, right in, center out, and tie. This is a left in, right out, left in, center out, and tie. This is a language we made up for the patterns of tie knots. And a half Windsor is all that. This is a mathematics book about tying shoelaces at the university level, because there are patterns in shoelaces. You can do it in so many different ways. We can analyze it, we can make up languages for it. And representations is all over mathematics. This is Leibniz's notation from 1675. He invented a language for patterns in nature. When we throw something up in the air, it falls down. Why? We're not sure, but we can represent this with mathematics in a pattern. This is also a pattern. This is also an invented language. And can you guess for what? It is actually a notation system for dancing, for tap dancing. And that enables him as a choreographer to do cool stuff, to do new things, because he has represented it. And I want you to think about how amazing representing something actually is. Here it says the word mathematics. But actually they're just dots, right? So how in the world can these dots represent the word? Well, they do. They represent the word mathematics. And these symbols also represent that word. And this we can listen to. It sounds like this. Somehow these sounds represent the word and the concept. How does this happen? And there's something amazing going on about representing stuff. So I want to talk about that magic that happens when we actually represent something. Here you see just lines, right, with different width. They stand for numbers for a particular book. And I can actually recommend this book. It's a very nice book. Just trust me. Okay, so let's just do an experiment. Just play around with some straight lines. This is a straight line. Let's make another one. So every time we move one down and one across, and we draw a new straight line, right? So we do this over and over and over. And we look for patterns. So this pattern emerges, and it's a rather nice pattern. It looks like a curve, right? Just from drawing simple straight lines. Now I can change my perspective a little bit. I can rotate it. And then have a look at the curve. You know, what does it look like? Is it a part of a circle? It's actually not the part of a circle. So I have to continue my investigation and look for, the true pattern. Now, perhaps if I copy it and make some art, well, no. Perhaps I should extend the lines like this and look for the pattern there. And let's make more lines. We do this. And then let's just zoom out and change our perspective again. And then we can actually see that what started out as just straight lines is actually a curve called the parabola. This is represented by a simple equation, and it's a beautiful pattern. So this is the stuff that we do. We find patterns and we represent them. And I think this is a nice day-to-day definition. But today I want to go a little bit deeper and think about what is the nature of this? What makes it possible? And there's one thing that's a little bit deeper, and that has to do with the ability to change your perspective. And I claim that when you change your perspective, and if you take another point of view, you learn something new about what you are watching, or looking at, or hearing. And I think this is a really important thing that we do all the time. So let's just look at this simple equation, like x plus x equals 2 times x. This is a very nice pattern, and it's true because 5 plus 5 equals 2 times 5, etc. And we've seen this over and over, and we represent it like this. But think about it. This is an equation. It says that something is equal to something else, and that's 2 different perspectives. One perspective is it's a sum. It's something you plus together. On the other hand, it's a multiplication. And those are 2 different perspectives. And I would go as far as to say that every equation is like this. Every mathematical equation where you use that sign, that equality sign, is actually a metaphor. It's an analogy between 2 things. You're just viewing something and taking 2 different points of view. And you're expressing that in a language. Have a look at this equation. This is one of the most beautiful equations. And it simply says that, well, 2 things, they're both -1. This thing on the left-hand side is -1, and the other one is. And that, I think, is one of the essential parts of mathematics. You take different points of view. So let's just play around. Let's take a number. You know, we know 4/3. We know what 4/3 is. It's 1.333. But we have to have those 3 dots. Otherwise, it's not exactly 4/3. But this is only in base 10. You know the number system, we use 10 digits. If we change that around and only use 2 digits, that's called the binary system. It's written like this. So we're now talking about the number. The number is 4/3. And we can write it like this. And we can just change the base, change the number of digits, and we can write it differently. So these are all representations of the same number. We can even write it simply like 1.3 or 1.6. It all depends on how many digits you have. Or perhaps we should simplify and just write it like this. I like this one, because this is 4 divided by 3. And this number expresses a relation between 2 numbers. You have 4 on the one hand and 3 on the other. And you can visualize this in many ways. And what I'm doing now is I'm viewing that number from different perspectives. I'm playing around. I'm playing around with how we view something. And I'm doing it very deliberately. We can take a grid. If it's 4 across and 3 up, this line equals 5, always. It has to be like this. This is a beautiful pattern, 4 and 3 and 5. And this rectangle, which is 4 by 3, you've seen a lot of times. This is your average computer screen. 800 by 600 or 1600 by 1200 is the television or a computer screen. So these are all nice representations, but I want to go a little bit further and just play more with this number. Here you see 2 circles, and I'm going to rotate them like this. And observe the upper left one. It goes a little bit faster, right? You can see this. And it actually goes exactly 4/3 as fast. And that means that when it goes around 4 times, the other one goes around 3 times. Now, let's make 2 lines and draw this dot where the lines meet. We get this dancing dot around. And this dot comes from that number. Right? Now we should trace it. Let's trace it and see what happens. This is what mathematics is all about. It's about seeing what happens. And this emerges from 4/3. I like to say that this is the image of 4/3. It's a very much nicer. Thank you. And this is not new. This has been known for a long time. But but this is 4/3. Let's do another experiment. Let's now take a sound. This sound. This is a perfect A, 440 hertz. Let's multiply it by 2. We get this sound. And we play them together. Sounds like this. This is an octave, right? Now we can do this game. We can play a sound, play the same A. We can multiply it by 3/2. This is called what we call a perfect fifth. Sound really nice together. Let's multiply this sound by 4/3. Right? What happens? You get this sound. This is the perfect fourth. If the first one is an A, this is a D. They sound like this together. This is the sound of 4/3. What I'm doing now, I'm changing my perspective. I'm just viewing a number from another perspective. I can even do this with rhythms, right? I can take a rhythm and play 3 beats at one time in a period of time. And I can play another sound 4 times in that same space. Okay, sounds kind of boring, but listen to them together. Hey, so I can even make a little hi-hat. Can you hear this? So this is the sound of 4/3. Again, this is as a rhythm. And I can keep doing this and play games with this number. 4/3 is a really great number. I love 4/3. I mean, truly, it's an undervalued number. So if you take a sphere and look at the volume of the sphere, it's actually 4/3 of some particular cylinder. So 4/3 is in the sphere. It's the volume of the sphere. Okay, so why am I doing all this? Well, I want to talk about what it means to understand something. And what do we mean by understanding something? That's my aim here. And my claim is that you understand something if you have the ability to view it from different perspectives. Let's look at this letter. It's a beautiful R, right? How do you know that? Well, as a matter of fact, you've seen a bunch of R's, and you've generalized and abstracted over all these, and you found the pattern. So you know that this is an R. So what I'm aiming for here is saying something about how understanding and changing your perspective is linked. And I'm a teacher, and I'm a lecturer, and I can actually use this to teach something, because when I give someone else another story, a metaphor, an analogy, if I tell a story from a different point of view, I enable understanding. I make understanding possible, because you have to generalize over everything you see and hear, and if I give you another perspective, that will become easier for you. Let's do a simple example again. This is 4 and 3. This is 4 triangles. So this is also 4/3 in a way. Let's just join them together. Now we're going to play a game. We're going to fold it up into a 3-dimensional structure. I love this. This is a square pyramid, okay? And let's just take 2 of them and just put them together. Okay, so this is what is called the octahedron. It's one of the 5 Platonic solids. Now we can quite literally change our perspective, because we can rotate it around one of the axes and view it from different perspectives. And I can change the axis, and then I can view it from another point of view. But it's the same thing, but it looks a little bit different. And I can do it even one more time. And every time I do this, something else appears. So I'm actually learning more about the object when I change my perspective. I can use this as a tool for creating understanding. I can take 2 of these and just put them together like this and see what happens. And it looks a little bit like the octahedron. But have a look at it. If I spin it around like this, what happens? Well, if you take 2 of these, join them together and spin it around, there's your octahedron. Again, a beautiful structure. If you lay it out flat on the floor, this is the octahedron. This is the graph structure of an octahedron. And you can even, I can continue doing this. You can draw 3 great circles around the octahedron and rotate it around. So actually 3 great circles is related to the octahedron. And if you take a bicycle pump and just pump it up, you can see that this is also a little bit like the octahedron. Do you see what I'm doing here? I am changing the perspective all the time. So let's now take a step back. And that's actually a metaphor. Stepping back, and have a look at what we're doing. I'm playing around with metaphors. I'm playing around with perspectives and analogies. I'm telling one story in different ways. I'm telling stories. I'm making a narrative, and I'm making several narratives. And I think all these things makes understanding possible. I think this actually is the essence of understanding something. And I truly believe this. So this thing about changing your perspective, it's absolutely fundamental for humans. Let's play around with this earth. Let's zoom into the ocean, have a look at the ocean. We can do this with anything. We can take the ocean and view it up close. We can look at the waves. We can go to the beach. We can view the ocean from another perspective. Every time we do this, we learn a little bit more about the ocean. If we go to the shore, we can kind of smell it, right? We can hear the sound of the waves. You can feel the salt on our tongues. So all these are different perspectives, and this is the best one. We can go into the water. We can see the water from the inside. And you know what? This is absolutely essential in mathematics and computer science. If you're able to view a structure from the inside, then you really learn something about it. That's somehow the essence of something. So when we do this, and we're taking this journey into the ocean, we use our imagination. And I think this is one level deeper, and it's actually a requirement for changing your perspective. We can do a little game. You can actually imagine that you're sitting there. You can imagine that you're up here and that you're sitting here. You can view yourselves from the outside. That's really a strange thing. You're changing your perspective, you're using your imagination, and you're viewing yourself from the outside. And that requires imagination. And mathematics and computer science is the most imaginative art forms ever. And this thing about changing perspective should sound a little bit familiar to you, because we do it every day. And then it's called empathy. When I view the world from your perspective, I have empathy with you. If I really, truly understand what the world looks like from your perspective, I am empathetic. That requires imagination. And that is how we obtain understanding. And this is all over mathematics, and this is all over computer science, and there's a really deep connection between empathy and these sciences. So, my conclusion is the following. Understanding something really deeply has to do with the ability to change your perspective. So my advice to you is try to change your perspective. You can just study mathematics. It's a wonderful way to train your brain. Changing your perspective makes your mind more flexible. It makes you open to new things, and it makes you able to understand things. And to use yet another metaphor, have a mind like water. That's nice. Thank you.